Welcome to the UGC lecture series. This is the E-Pathashala lecture series, and we are talking about the subject called computer science, in which the paper we are going to talk about is machine learning, and this particular module explains a particular classification algorithm called KNN, the expanded form of which is K nearest neighbors. And these are the people responsible for the creation and construction of this module, and we will now talk about the learning objectives of this module. The learning objectives are to explain the concept and the methodology of the K nearest neighbor algorithm, to discuss the issues in choosing a particular value of K, and we are going to illustrate K nearest neighbor algorithm with examples, and then we are going to discuss the strengths and weaknesses and some of the applications of K nearest neighbor. It is one of the very common algorithms that is used for classification, and so we are going to look at what are the applications also for this. And some of the keywords that we have are neighbor, non-parametric, distance measure and feature normalization. So, let us go in detail about one particular algorithm. We are going to go in detail into that algorithm, which is called the K nearest neighbor. So, first let us introduce what we mean by K nearest neighbor. We have already discussed the basic concepts of nearest neighbor in the previous module. Here we are talking about a particular algorithm. So, the K nearest neighbor algorithm, called KNN for short, is a non-parametric method which is used for classification and regression. What is this non-parametric method? We are only using instances, we are not building a model. So, there is no parameters involved. We have discussed this in general for nearest neighbor, and we are talking about both classification and regression. We have already seen this in previous modules long back. Classification is to do with discrete values, while regression is supposed to do with continuous values. Now, in both cases the input consists of K closest training samples in the feature space. In both cases we are considering the K closest training samples in the feature space. So, feature space is that space in which we plot the input points, and the closest is the measure, distance measure that we use to find the closest. So, that is the meaning of closest, using distance measure. The output depends on whether the KNN is used for classification or regression. If it is used for classification, the output will be different. If you use it for regression, the output will be different. Now, in KNN classification, the output is a class membership. So, this particular training unlabeled sample belongs to one class or belongs to another class, that is the output. In KNN regression, on the other hand, we have the output is a property value of the object. So, it is a different, slightly different, it is a property value of the object. And there are other terms that are used for KNN, K nearest, this all mean the same thing, K nearest neighbors, memory based reasoning, example based reasoning, instance based learning. So, all these are terms that are used for K nearest neighbor. So, instance based learning is a general term of which KNN is one method, example based because we are using examples for classification, memory based because we are using the input instances and putting it in a space and then using the algorithm to classify an unlabeled sample. It is also called as case based reasoning. In case based reasoning, it is a much more complex values are there in the instances. So, let us take an example. This is taken from this particular university site and these slides. So, the simplest machine learning method of all, that is the K nearest neighbor. So, here we have two classes, blue stands for down and green stands for up, and this is the input samples that have been plotted in Euclidean space, okay. And that green and blue tells me this, that particular point is labeled as green or labeled as blue, which is in this case up and down. Now, a new point comes into the picture. So, that is red, this is still unlabeled and it should be classified as either up or down. Now, what will it be classified as? Now, that depends on the value of K. So, if you have a 3NN classifier, that means 3 nearest neighbors. If you look here, you have unlabeled sample and around it you have the neighbors. You see that 2 blue neighbors and 1 green neighbor, the majority is blue, and so it is classified as blue or down, in other words. Okay. So, this classification depends on the number of neighbors you take also. So, suppose we have 3NN in 2 cases and we will see whether it is correct or not. Now, suppose you take the first case, okay. The first case, you have that, what will it be classified as? It will be classified as, if 3NN we are taking. So, it will be classified as here in this case it will be classified as blue, but actually it is very near to green. The other case it will be classified as again red is near one blue, one green and probably one blue. So, again it will be classified that way. So, it depends very much on how many you take as k. It will be an odd number obviously. So, 3 and 5 are typical values that is taken. So, this is, will it always be correct? No. We call k nearest neighbors as also learning by analogy, because tell me who your friends are, then I will be able to tell you who you are. So, that is the example they use. So, a new label is assigned to the most common class among the k examples that are used for comparing with it. Okay. So, classifiers, there are many types of classifiers. One is a classification tree, we have not gone into detail about this, but this is a typical classification tree where we see age is greater than 0, these are parameters. If it is yes, you go and check the next parameter. If it is no, if age is greater than 40 is no, then it cannot be, there is no class is no response. If it is yes, then you check the income. If the income is greater than something, then you say no. Otherwise, you come here and so on. So, finally, you have an S value. This is a decision or classification tree. In the k nearest neighbor, we just take all the neighbors and you decide on how many neighbors to consider, and depending upon that, we will give the response. So, the definition of k nearest neighbor is, k nearest neighbors of a record x are data points that have the k smallest distance from that x. So, if you look there, this is 1 neighbor, this is 2 neighbor and this is 3 neighbor. If you look at this data point, in the first it is classified as negative, which is 1 neighbor. If it is 2 neighbor, you cannot classify it because both are coming into the picture. If you take the third one, it will be positive, classified as positive. So, you understand the importance of distance and the value of k. Now, let us look at it is the internals of the k nearest neighbors algorithm. One, it is a non-parametric method. What is the meaning of this? We have already told you that k nearest neighbor is the type of nearest neighbor. Nearest neighbor is a type of instance based learning method, and that is a type belongs to the class of classification learning algorithms that are lazy. That means it does not form a model. It just stores all the input instances. There is no model that is built. Unlike other supervised learning algorithm, k nearest neighbors does not learn an explicit mapping f from the training samples. It simply uses the training data at the test time to make predictions. Any processing is delayed or is not done. It is delayed until a new instance or an unlabeled instance or a query instance come. Both are, all the three are synonym terms. They come, and at that point of time you find out the neighbors and you do all this. So, unless you get the test point, all the points are just mapped and stored, mapped into Euclidean space. And so, to determine the class of a new example E, what do? We calculate the distance between that example E and all the examples in the training set. Okay. And then you sort the distances in ascending or descending order, whichever you want, and use the sorted distance to select the k nearest neighbors to E in the training set. Okay. And then assign E to the most common class among the k nearest neighbors. You use the majority rule for classification and averaging rule for regression. So, this is the basic k nearest. What do? You determine the class. To determine the class, you have to calculate the distance between that example and all the trainings. Then you sort the distances, then select k. So, what are the issues here? How to calculate the distance, what is the value of k. So, these are the two, and after you do that, what is the rule you use to decide on the classification? Is it a majority rule or is it an average rule? So, the steps you have are: store all the input data in the training set. For each pattern in the test set, search for the k nearest pattern to the input pattern using an Euclidean distance measure. And for classification, compute the confidence of each class, that is the majority, Ci by k, where Ci is the number of patterns among the k nearest patterns belonging to the class I. So, that is what we did, majority rule. The classification of the input pattern is the class with the highest confidence factor. This is just we are putting the confidence here, majority rule is almost the same as that. Now, there comes a question of how do we choose the value of k, because as you saw on all the examples we saw, depending on k, your prediction is either, we took Boolean examples, it is either this or that. No, that is not a good classification methodology. So, choosing this k is very, very important. So, how do we choose k? Often it is data dependent, or you use a heuristic method, or you can use cross validation. We looked at evaluation methods in the last module. You can have held out data, so that you are sure of the classification, or you can choose, normally you choose an odd value, so that you eliminate ties. You saw in the 1 or 2 slides back, we used 2n and we found that one was positive, one was negative. What do you what do you classify the new sample as? So, that is the problem. So, in general, a k too small or too big is also bad, that does not solve our problem. If you choose a small k, what happens? It creates too many small regions for each class, because every small k will form a region, and it will lead to non-smooth distance boundaries and sometimes overfit, because only exactly if it comes into that value you will get the class. If k is too small, it will be sensitive to noise points also. If it is a large k, what is the problem? It creates fewer regions, but you may miss some classes. It leads to smoother decision, so underfit, that is a problem here. If k is too large, neighborhood may include points from other classes also. So, that is the disadvantage. So, you have to choose an appropriate value of k. So, choosing k is a very important part of this algorithm. So, now let us look at the training parameters and typical settings that you have for this particular type of algorithm. So, the number of nearest neighbors is an important part, which we saw k. The number of the nearest neighbors k is based on cross validation over a number of k settings. So, you can keep on giving k's and testing the values and see which k gives you a good value. This will, since you have cross validation, you can use that to choose the value of k. Again, remember, in any classification, the sample test data set that you give should be a representative of the classes that you want to use, classify. Otherwise, this cross validation also will not work. Then when k is equal to 1, you have a good baseline method to which benchmark to test against. A good rule of thumb numbers is k should be less than the square root of the total number of training patterns. So, that is one rule of thumb. It is not a given rule, but it is just a heuristic. Next, so that is the number of nearest neighbors, that is one of the issues. Next is the input compression. Since KNN is very storage intensive, compress data patterns as pre-processing step before classification. So, this can be done. So, otherwise all the data points you have to store. So, that but how do you compress? Because it may result in worst performance. So, the compression should be done in such a way that it goes along with the classification, which is again a pre-processing. Sometimes using compression can improve performance because it does some sort of automatic normalization of the data, but it can and it can equalize the effect of each input in the Euclidean distance measure, but that depends on the type of compression and this type of data also. Now, let us look at distance measures and feature normalization. So, the common distance metrics that are used are Euclidean distance is the very common method. The distance between any 2 points p and q is nothing but the square root of the summation of all the dimensions pi minus qi the whole square. So, this is the Euclidean measure. If you have 2, it will be x1 minus x2 the whole square plus and so on. So, the number of values in that summation will be the number of dimensions. Next is something called Hamming distance or overlap metric. What we do for this is we use an overlap metric to find out the Hamming distance. Next is you also use a Boolean metric sometimes. Okay. What is the, if x is equal to y, then the distance between x and y is 0, if otherwise the distance is 1. So, that is the Boolean metric. So, these are some of the metrics used. And the feature normalization, features should be on the same scale, otherwise you can't compare. Example, if one feature has its values in millimeters and another feature has its values in centimeters, we will not get a appropriate dimension will be skewed towards the sum of one of the features, and so we will have to normalize. One way of doing it, this is to replace x by z, where z is nothing but the value of x minus the mean divided by the standard deviation. So, mu is the empirical mean of the mth feature, and this is the variance of the mth feature. Next is the distance weighted nearest neighbor. We will discuss this slightly in the last module. So, KNN can be refined by weighing the contribution of the k neighbors according to the distance to the query instance. giving greater weight to close neighbors. This is very important. So, what I am saying is I am having one particular instance and surrounding this I have k neighbors. KNN means k neighbors. Now, suppose the distance between this instance and the first neighbor, let us say k is 3 or 5. The first neighbor is say some x and the second neighbor is y and third neighbor and so on. Now, x is closer means that is given more weight and y is like that. So, you weigh the neighbor gets as much importance as it is closer to the input instance. So, that is another way they do distance weighted nearest neighbor. Now, let us see an example of 3 nearest neighbors. Here we have customers Shiva, Sweta, Raji, Bala, Kavita and Kumar, and we have their age, income, number of credit cards, and we are expecting a response to a questionnaire we are saying or a facility we are providing for these particular people. So, given these we want to find out what will be the response, or we want to classify or predict the response of, this is a prediction problem basically, we want to predict the response of Kumar. So, here we are assuming distance between neighbors. The features of the neighbors are represented as a set of numerical attributes, all are numerical, and here we have Shiva. So, we will Shiva has age of 35, income of 35k and number of credit cards is 2, and we have Sweta, again age 22, income 50k and number of credit cards is 2. You see that the response of one person is no and the response of the other person is yes. Okay. Now, what we are trying to do is we are trying to find the distance between Shiva and Sweta. For that what we have to do, we have to have a closeness, we have to find what is, how do we define closeness. In this particular example, we are trying to find the Euclidean distance between these two samples. These are actually samples or data points in the Euclidean space if you visualize it like that. So, the Euclidean distance between any two data points x and y, x can be any number of dimensions n. But in this particular example, we are having only how many dimensions? 3 dimensions, age, income and number of credit cards and the response also. So, sometimes you will consider the response or you need not consider. Here we will take only the 3 attributes and we have the distance between Shiva and Sweta as square root of, this is we are following the Euclidean measure, the summation of square root of the summation of the first attribute 35 minus 22, second attribute 35 minus 50, the third attribute 3 minus 2. So, the distance between Shiva and Sweta is given as the square root of the values of these attributes. So, with this we will go into the next and we will see how we will find the distance of between the 3 neighbors. We will take 3 neighbors and we will see what value Kumar will get when we do the prediction. So, here the distance from Kumar is given here as this is a slightly varied example. So, here we have the values for each and we find that 3 values, that is 15.16, 15 and 15.74. These are the 3 nearest neighbors to Kumar. So, that is Shiva, Sweta and Kavita are the nearest to Kumar. So, that is what we find out from here. So, you can also do normalization. So, how do we do normalization? We take the maximum value, okay, and divide it. So, here in this particular example 63 is the maximum value. So, each of the values are divided by 63. The second one 200 is the maximum value, divide each of the values by 200. So, maximum I mean that 200 will have a value of 1 and then the next one you divide it by the maximum value which is 4. So, this is one way of doing normalization, simplest way, divide the actual value by the maximum value. So, the distance between neighbors could be dominated by some attributes with relatively large numbers. So, that is why for example, the highest income is 200. So, Kumar's income is normalized as 50 by 100 and Bala's is normalized as 170 by 200. So, what will happen is if we normalize we have but some of the attributes you cannot normalize, for example, married, how will you categorical attributes, how will you normalize, that is a little difficult by this method. So, what are the strengths of KNN? The strengths of KNN are simple to implement and use, comprehensible, very easy to explain how you did the prediction, how you did the classification. It is robust to noisy data because you are averaging the k nearest neighbors, okay. And there are some very appealing applications available. The cost of learning is almost 0 because we do not build a model. There are no assumptions, there are no characterization of the concepts and so on. Complex concepts can be learned by local approximation using simple, very simple procedures. Okay. So, what are the weaknesses? need a lot of space to store all the samples. As you get more and more samples, the better is your output. Takes more time to classify a new example than with a model. This is the typical disadvantage or weakness of lazy learning methods, which KNN is one. The model cannot be interpreted because you do not have any model to interpret. It is computationally expensive to find k nearest neighbors when the data set is very large, because for everything you have to find the neighbors and then only you can find the k nearest. Performance depends on the number of dimensions that we have. So, suppose you have 20, 30 dimensions, it is very difficult. So, one method you can do is you can do an attribute selection. KNN's disadvantage is that it uses all the instances to classify the new instances. This is obviously because it takes a new instance and compares it with all the instances that is available. So, that is one of major disadvantage of KNN. So, one of the solution to that is weigh the attributes differently. So, use cross validation to determine which should be weighed more and so on. So, this is one solution. The second solution is you eliminate the least relevant features. Again, you can use cross validation to determine which of the attributes you want to eliminate. That is also possible. Now, some of the other issues associated with KNN is the curse of dimensionality. The more dimension we have, you have to have more examples to reach a to approximate to a hypothesis. The number of examples that we have in a volume of space decreases exponentially with the number of dimensions. So, that is the problem. In each of the spaces, that hypothesis space we are talking about, as the number of dimensions increases, the number of examples that you need also increases if you want to have examples in each of the hypothesis space. So, this is especially bad for k nearest neighbors method, this curse of dimensionality. If the number of dimensions is very high, the nearest neighbors, what we call as nearest neighbors, can be very, very far away. So, training this model also includes setting the parameters. So, the variable k, validation techniques can be used, cross validation can be used to find out what that value of k should be. The type of distance metric, as we already discussed, is very important. Euclidean measure is the common measure that is used, but there are others possible. This is the Euclidean measure which we have already seen. And some of the applications of KNN is very, very commonly used. So, we have to look at the applications. So, nearest neighbor based content retrieval is very common, handwritten content retrieval, video content retrieval. Graph based KNN is also very much used. For example, protein-protein interaction and 3D structure prediction in gene expression, that is used. Classification and interpretation, for example, legal, medical news, banking, credit. Banking is where credit rating. Problem solving also it is used in planning, in pronunciation, these are places where it is used. And function learning also it is used in dynamic control, teaching and aiding it is used in help desk, user training. Areas of application in all this in general we have looked at different places is bioinformatics, very commonly used is KNN. Image processing and data compression, KNN is used. Document retrieval, KNN is used. Computer vision is another place. Multimedia databases, marketing data analysis, all these places KNN is used. So, why is KNN used so largely? Because classification is very important in almost all these applications, and data is available. You will see that it is used when data is available. At the same time, it is also used because it is a very simple algorithm to implement and also to understand. Why is it doing it like this? We can understand. So, if you choose everything appropriately, the correct value of k, the correct appropriate features, and also if you do the weighing appropriately, you can get a very efficient KNN algorithm for the application of your choice. You look at the type of problems that it solves. One is graph based, one is nearest content retrieval, classification, problem solving, function learning, teaching and aiding. All these types of problems it is used. So, let us look at what we have covered in this module. We have explained the concept and outlined the algorithm of k nearest neighbors. We have discussed the importance of choosing k. We looked at what a small k will do and what a large k will do. You have to choose the correct k. And we have also explained k nearest neighbor using an example of some people along with their age and the number of credit cards and all. And we discussed the strengths and weaknesses of k nearest neighbor. And we also ended up our module by listing some typical applications of k nearest neighbor. It is a very, very extensively used algorithm for in machine learning for classification. Thank you.